Recording.
Okay. Okay, shall we start the meeting, folks?
Go for it.
All right, well, welcome everyone to the February meeting of the Stockton Astronomical Society. Tonight we have a wonderful guest speaker. I'm going to have Fred introduce him, of course. And I want to wish Jeff a happy birthday. It's tomorrow, right?
It is tomorrow.
Yeah. And how young are you?
63.
All right. Looking forward to retirement soon, probably, which is a good thing.
Die, retire, whichever
Whatever,
comes
yeah.
first.
All right. Okay. Anyone else have a birthday in February?
George
Right, that's
Washington.
good. Well, no. In the club.
Lincoln.
Really? I didn't know that.
He's my birthday.
I'm kidding.
You dumbass.
Okay.
Oh, and Arsenio Hall and Charles Darwin.
Oh, yeah. Okay. Well, I'll be sure to wish Charlie a good time. Anyway, all right. Let's continue on here. Fred, you might as well go ahead and introduce our guest speaker. We're really looking forward to this. It should be a wonderful speech here, talk.
Okay, very good. So we do have a real treat tonight. Don Machholtz is with us, and many of you know him from legendary comet discoveries, his podcasts, and his Messier marathons. So Don was born in Portsmouth, Virginia on October 7th, 1952, and became interested in astronomy at the age of 8. He received his first telescope on October 7th, 1965, which was a 2-inch refractor. Later, he received a 6-inch Criterion Dynoscope and found all the Messier objects in 1 year. Then Don spent some time with astrophotography from 72 to 74, having a few photos published in small astronomy magazines. He decided to attempt comet hunting program, which began in January of 75. He found his first comet in September of 78 after 1,700 hours of searching. His second find took an additional 1,742 hours. He now has over 8,000 hours comet hunting, during which he has discovered a total of 12 comets, which bear his name. Don is #1 living visual comet discoverer. In 1990, Don and his late wife, Laura, and their son, Matthew, moved from San Jose, California to Colfax, where they lived for nearly 30 years. From here, he discovered 8 comets and held numerous public star parties. During 1978, Don was one of the independent inventors of the Messier Marathon, an attempt to find and view all 110 objects, clusters, and nebula in one night. In the last 40 years, he has completed over 45 Messier marathons and has written 2 books on the subject. I think I've done 45 Messier objects. From 1978 to 2000, Don wrote the monthly column called Comet Comments. It was designed for Astronomy Club newsletters and interested individuals worldwide. Between 1978 and 2000, Don was the comet hunter, was the comet's recorder for the Association of Lunar and Planetary Observers, also known as ALPO. Don continues his visual comet hunting and Messier marathons from Arizona, where he lives 19 miles off the road with no power and no lights, all off solar, off the grid type thing, where it's probably very, very dark, with his wife, Michelle. Don has weekly podcasts called Looking Up with Don. And if you have never listened to one of these, listen to one of them. They're really good, quite enjoyable. He also has a website, donmachholtz.com, and you can reach him at a variety of post office box, email addresses, and other contact information. Ladies and gentlemen, it is my privilege to introduce who is with us tonight, Don Machholtz.
Thank you very much, Fred. Appreciate that. Okay, can we see the screen?
Yep,
Yes.
test slide number 2.
All right. By the way, I did a Messier marathon last night. About this time of the night, I was beginning my February Messier marathon, saw 103 objects overnight, which is the most you can see this time of year. As Fred mentioned, I have a podcast every week. Every Wednesday, we drop a new one out there, and Looking Up with Don lasts about 15, 20 minutes, what's up in the sky and tidbits of information. The website is donmachholtz.com, and my podcast, I did cover the Messier Marathon podcast 5 to 11 that you can get off my website. Here's something. So I'll be talking tonight about the Messier Marathon, and talk should last probably about 40 minutes at the most. The last section of the talk, we actually walk through the Messier objects in the marathon order for late March Messier Marathon. So how to run a Messier Marathon. The popularity of Messier Marathons has increased over the decades. I wasn't so sure at the very beginning that people would really take this thing on, but they have. It all started with Charles Messier, who passed away just a little more than 200 years ago. He lived in France, and he was good at organizing things. He was a map maker, and also he worked at the Paris Observatory. He made his own star maps. When a comet came by, he would make a map and put the comet on the map in its appropriate place. We can see the Paris Observatory over the years. And he did discover comets. He has 12 comets that bear his name, and one more that bears the name of Lexell, who helped to calculate the orbit, which ended up being a lost comet because it went too close to Jupiter. But here we have the comets that he discovered. The ones in red were found in the southern hemisphere. And at the far right, we can see if he found it with a telescope or the unaided eye. The magnitudes, these comets were fairly bright when discovered. There was not much competition. Back at the beginning in 1760 was the first year in which the name of the discoverer was put onto the comet. Charles Messier attempted to find Comet Halley on its return, and he was not given the correct positions by his boss. He did find it, but he found it a couple months after it was officially picked up by a guy in Germany. So he didn't get credit for recovering it. And his observations, which occurred weeks later, were not released to the public by his boss for another couple months, which was probably quite frustrating for him. It seems like Charles Messier was the first person to begin searching for comets in a competitive type of way. Back then, usually the first person would get their name on a comet unless it was a really bright comet. And then it would sometimes just be called the comet of that year. Now, he also picked up other comets that were found by other people. We can see on the far right how many days he was behind the actual discoverer of that comet. And that still happens even until the last few decades, in which visual comet hunters would go out and find a comet and then find out as they reported it that it was picked up by others. It usually depends more upon bad communications than anything else. That's happened from time to time over the last 200 years. He published catalogs of these fuzzy objects that he would pick up, because when a comet is first discovered, it usually appears as a fuzzy object through the telescope. Now, Messier used a 3-inch refractor. He also used a 6-inch reflector, which had a silvered mirror. Our telescopes nowadays would probably gather, a 6-inch would gather more light than what his telescope did. And his refractor had a fairly narrow field of view. And sometimes he would use it at magnifications as high as 100. The eyepieces were the things that quite often would hold back, giving you a wider field of view. He published a couple catalogs. The first one had 45 objects. We've often wondered why it was 45 and not some other number, because the last 4 objects seem to be kind of rushed in there, 42 through 45. But these were objects that he observed. He did not necessarily discover all of these objects. And when he would write about them, if he knew who discovered them, he would say so. This was found by so-and-so or by so-and-so. We find that the first 45 was a lot of stuff in the Milky Way, a lot of brighter stuff. And then in the later catalogs, it was much dimmer, more galaxies. In March of 1781, I believe it is, he began finishing up his second catalog of 103 objects. And he seemed to kind of rush through those in about the last couple months. He made a couple errors when he did that. And we have figured out what those errors are. So there used to be some confusion about the Messier objects. When I wrote my first article about the Messier objects, I talked about the 107 Messier objects. And the AANC, the Astronomical Association of Northern California, recognized at that time only 107. They did not recognize M110, M91, and M102. We now know that we now seem to understand what all of those objects are, so we do have the full 110 objects. M24 is a star cloud. It doesn't have an NGC number. It's about 1.5 degrees by 3/4 of a degree in size. And we ask that when you do the marathon, you find that cloud. There is a tiny open star cluster in there, but the M24 is actually the complete cloud. M40 is a double star. Charles Messier was told by another astronomer that it seemed to be a fuzzy object to them. So he looked at it. He didn't really see much nebulosity, but he put it in his catalog. It's near the Big Dipper. It's the middle star of the Big Dipper, the one between the bowl and the handle. And it's about 1.5 degrees north of that star, about 9th magnitude. M73 is 4 stars. Charles Messier thought it looked a bit nebulous. And as a comet hunter, that happens to us. Sometimes we'll find 2 or 3 or 4 stars close together, and they will appear to be a fuzzy object. I have a lot of those in which I had to finally resolve it using either higher magnification or making a sketch and seeing that it doesn't move. M91 was a missing object until the late 1960s. A guy named Williams wrote a letter to Sky and Telescope, and he discussed about how this can be a known galaxy. This theory may be correct. I'm not really sure. Possibly M91 could have been a comet passing through the area. It seems like Charles Messier observed it on only one night. So if it was a moving comet, he probably would not have noticed it. But if we want to assign an object to it, there's a reasonable explanation as to why it's missing. Over toward the left side of the screen, closer to the top, you have an open black circle. That's the position that Charles Messier gave for this object. And as we can see, there's no galaxies there. There's nothing there. And this shows stars down to 10.5 magnitude. But there is an object that is known as M90, now known as M91, a little bit to the right of that. The theory is that when Charles Messier measured the position of M91, he measured it, he thought he was measuring it off of M58. And so it was like 2 degrees north of M58. And so that's how he plotted it on the map and got the position. And there's nothing there. But if he was looking at M89 and measuring it off of M89, and you go the same distance in the same direction, we do get to a galaxy known as 4548. 4548 is about 9.5 tenth magnitude. It's one of the faintest ones in the Virgo group of Messier objects. However, it does seem to fit the bill as possibly it's in the correct position if he in fact made that mistake. And it would be bright enough that he would have seen it. One problem we have is that the objects seem to go from right to left. And we have M91 now before M90. But if he thought it was in the open black circle, then they would be in order. And he might have numbered it then after he had plotted it on the map. M102 seems to be 5866. Sky and Telescope magazine does not recognize that. Sky and Telescope magazine says that M102 is the same as M101, and there is a good reason for that. Charles Messier probably did observe this object. It was Messier who brought it to his attention. Charles Messier seemed to have plotted it on the map, but it seems like he plotted it 5 degrees off. His map has been found. It does have a mark 5 degrees off, or 20 minutes of right ascension on the map. Now, the right ascension lines were every 20 minutes of right ascension. So it looks like he plotted it in reference to the wrong line. About 10 or 15 years after the position and the information was published, his partner, Pierre Machholtz, wrote a letter not to the French magazine that had originally printed the catalog, but to a German magazine. And he said, you know what, we made a mistake. There is no M102, so it must have been a duplicate observation of M101. That letter seems to seal the deal. However, the description of M102 is much different than the description of M101. The fact that Messier misplotted it seems to indicate that perhaps Messier used Messier's map, went out and looked for that object where Messier said it was, and could not find it. And he, what's going on here? Well, we must have just looked at M101 again. He might have came up with that theory because he could not find it based upon it being plotted wrong on the map. That's not the only object that's plotted wrong on the map. M48 was off by 5 degrees. There was another Messier object that was off by a few degrees. So Charles Messier did a pretty good job, but on a few areas, he did seem to make a couple mistakes. Now, the final object is M110. As I said, Sky and Telescope magazine does not recognize M102. Astronomy magazine does not recognize M110. Each magazine says there's 109 Messier objects, but they have a slightly different list. M110 seems to have been observed by Charles Messier. It is a satellite galaxy of the Andromeda Galaxy. Now, the Andromeda Galaxy has 2 of them. One is M32. The other one is an object, and it seems to be plotted on a map that Charles Messier made down at the bottom. So he observed it, he plotted it, he did not specifically give it a number. It was Glenn Jones who in 1968 wrote a major volume on the Messier objects, who put it into the Messier catalog and suggested that it be included. So that's how we get our 110 objects. Now, these objects are scattered throughout the sky. You have here's a map of the sky. North is at the top, south is at the bottom, and right ascensions listed across the bottom of the map. Beginning on the upper left and going down and a little bit to the right, we have the Milky Way objects, with the center of our galaxy being toward the lower left. The Milky Way objects are also toward the right, near Orion, Gemini, Auriga, a lot of open star clusters, nebula, and so on. In between those areas where we can see further into space beyond our galaxy, that's where you have a lot of other galaxies. And near the center, we have the Virgo group of about a dozen galaxies. And that whole area has galaxies both north and south of there. Now, the sun goes around the sky because we go around the sun. So as we go around the sun, objects rise and set 4 minutes earlier each night. And the sun is in the vicinity of many of the Messier objects. You might notice too that the planets also pass by a lot of the Messier objects. So whenever the sun is in the vicinity of these objects, we cannot see those objects because they are in the sky. After morning twilight, when the sun comes up, then they're in the sky, but you can't see it because the sun's in the way. If you wait a month or so, the sun moves out of that area, and then those objects become visible first in the morning sky, and then over the months, they move to the midnight sky, and then a few months later, they're in your evening sky, and then they go behind the sun again. So because of that passage, there's times when certain objects are visible and certain objects are not visible. I noticed this as I was doing comet hunting at Loma Prieta in the Santa Cruz Mountains in the late 70s. I spent almost 3,000 sessions at that mountain over 15 years and found 3 of my first 4 comets from Loma Prieta. And I was especially interested in what happens in the evening sky. Facing the west, you have a series of objects setting. Down toward the bottom, you have M77, then you have M74, 33, and then the Andromeda Galaxy group. Now, a month later, those objects will have already set by evening twilight. So if you want to observe them, you have to get them before late March. And if you look at the whole sky in the evening, this is the evening star map. The big circle is the horizon. Everything inside the circle is above the horizon. Everything outside the circle is below the horizon. And the western sky is to your right, because if you face south and hold this overhead, then your directions are aligned properly. And you can see off on the right, you have some of those objects setting, those galaxies 77, 74, and so on. Running fairly high in the southern sky, you have the winter Milky Way objects. And rising in the east, you have the bunch of galaxies. As the night progresses, these objects move across the sky. As we see it, they move pretty much from left to right, so that by morning, those galaxies are now in the west, and a new crop of objects have risen and have taken their place. So late 1970s and 1978 in August, I wrote an article for the San Jose Astronomical Association. That was also the month I wrote my first comet articles, August of 1978, and a month before my first comet discovery. And I suggested we all get together next March and do the Messier Marathon from Loma Prieta.
Real good.
At that time, there was a astronomer by the name of Walter Scott Houston, and he wrote for Sky and Telescope, a very popular column for Sky and Telescope each month about the deep sky objects. And little did I know that come next March, he wrote an article about something that he called the Messier Marathon. And three people had already been doing that across the United States. And this was the first time it was publicly mentioned. And they talked about the number of objects that they could see and the number that they had seen. This map was in that magazine in March of 1979. And it shows the critical portions of the sky for twilight times. On the left side of the screen, we have the evening sky. And that white band going from the lower left to the upper right is your horizon at nautical twilight and astronomical twilight from mid-northern latitudes. And you can see those objects, those galaxies setting in the evening sky in the evening. Now, 8-10 hours later, you turn around, you have on the far right, on the right portion of the screen, the morning sky. And you can see that band going from the upper left to the lower right, showing astronomical and nautical twilight, and where those objects are in the sky just before dawn. I wrote an article for Astronomy magazine about it because Walter Scott Houston's article was in Sky and Telescope. And they put me in the forum, which was kind of like for minor articles. I had asked if I could write more of a feature or a longer article, and they said, no, we'll just put this in the forum. So they did. And first time it was mentioned in their magazine. And here's some of the founding members of the Messier Marathon. Now, the people at the top seem to have known each other in the late 70s. Tom Ryland, still active in astronomy. And these are the number of objects they found each of those years. The ones in red were the first time those number of objects were ever seen in one night by somebody. And Tom was probably the first that was kind of sitting around with, I think, the other Tom. And they said, we could maybe see how many Messier objects we can see. So they began doing that. Tom Hofeller lives near Las Vegas now and is still active in astronomy. I don't know about Ed Flynn. I began doing the Messier marathons in March of 1979, and I was the first to see 107, 8, and 9 objects. And Jerry Ratley, who passed away a couple years ago, but he lived at that time in San Jose, was a member of the San Jose Astronomical Association. He was the first person to see 110 objects in one night. And the next guy was about an hour later in Southern California that year. Now, if you want to run a Messier marathon, it helps to get away from the city lights. You do need fairly dark skies, not just to be able to see them through your telescope, but if you have good dark skies, you can usually see half the objects through your finder, and that makes them easier to see. Can a person use a go-to telescope for the Messier marathon? Yes, they can, and many people do. It does take away the challenge of finding the objects, and it is an unfair advantage when compared to those of us who star hop from object to object. That is most significant when you have cloudy weather, partly cloudy weather where you have cumulus clouds which hide portions of the sky as they drift across the sky. Those of us who visually search have a little trouble star hopping when you have only tiny holes in the clouds. Those with the automated electronic setting circles merely tell their telescope to point to a certain area, and then they wait for a hole in the clouds to see it, and then they can move on to the next object. But in all respects, using automated equipment to do the Messier marathons perfectly fine, and probably a third to a half of those who do the marathon do use some type of electronic setting circles. You want to avoid the moon, but we try to have it at new moon, but that's not really necessary. I once did the Messier marathon when the moon was 3 days past full, which means it's a really bright moon that rises about 2 hours after twilight. Most of the fainter objects are in the evening sky. So I picked up everything down through the Virgo group by moonrise, and then I just had to battle the moon a little bit in the morning sky. Now, the moon does pass through a lot of the Messier objects. Once when the moon was near M1 last year, even with a 16-inch telescope, I could not find M1. 10 years ago, the moon was up near M67, an open star cluster in Cancer. I did finally find it, but it was very difficult in the bright moonlight. And last year, I was doing the marathon, and the moon in the morning sky, about 30 to 40% full, was near M8 and M20, and that made it very difficult to find those objects. The moon can be near M1 when it's about 30% full in late March, so you do have to be careful of that. If you want to see well, I've learned that these are the three areas that you should work on: your eyes, the skies, and the telescope, probably in that order. The more you look, the more you see. If you practice seeing faint stuff, you'll do better at that. Here we're working for finding low contrast objects. You work on that. Your skies are also very important. Third would be the telescope. Does that mean a bigger telescope does not help? No, a larger telescope does provide a better view of some of the fainter objects down near the horizon. But for 95% of the objects, anything usually more than a 2 or 3 inch telescope should be able to pick all of those up. It's just those that are setting in the evening, and sometimes in the morning you have some difficulty, and a larger telescope does help in those cases. We want to have a low horizon for the Messier Marathon in 2 directions, from the east-southeast over to the south-southeast. So in the southeast area, you want to have a fairly low horizon, especially if you do the Messier Marathon in late March. If you do it in April, it doesn't matter. And you also want to have a low horizon from due west to the northwest. That doesn't matter so much if you do the Messier Marathon in early March, but as you get near the end of March, you would like to have a low horizon, at least no more than 5 degrees high or 4 degrees high, in order to pick up those objects there. People like to do it on the weekends. I have not limited myself to the weekends, and I find I can have a lot more flexibility with the weather. Usually the Messier Marathon begins at 7:30 or 8 in the evening, and it's over by 5 a.m. And when I do it, I sleep for 5 or 6 or 7 hours in between. So you can still go to work, and that week, if you do it on a Wednesday night or something, you'll still be fine for Thursday, probably, if you get some sleep overnight, and still do the Messier Marathon. But most public start parties and private start parties where the marathon is done are usually Saturday nights. Now, latitude does make a difference. If you get too far south, guess which object you lose? M52. The other objects, though, probably the best latitude is about 20 degrees. As you go further north, you begin to lose some of the other objects. And it becomes a little more difficult to pick up some of the morning objects in the southeast, such as M55 and M75. They rise a little bit later in the morning the further north you go. So here's a number of objects number of days that these number of objects are visible each year from these latitudes. I've done a lot of Messier marathons. And here's my list of Messier marathons. The ones in red were not completed mainly because of weather. I do it in 2 sessions. The evening, I do the first 64, 65 objects, all the way down to M104 or M68. And then I'll take a break. If I'm by myself, I'll just go in the house, go to bed. If it's a public star party, I'll make the rounds, say hi to everybody, and go to bed. And then I'll get up in the final 2 hours and do the rest of the objects. Sometimes you get up at 2 or 3 a.m. and it's cloudy. So, you don't get all the objects. In the early days, I would do it on a Friday night and then go back again and do it again on a Saturday night, trying various observing orders in the first year or two to nail down a really good observing order that would work for everybody. In number 9 in 1984, I did it when the moon was 3 days past full. Number 6 and 40 years ago, I did something called the Massive Marathon, in which I viewed 599 objects in one night, 1 object every 52 seconds. And I used star charts, no setting circles, an equatorial mount, the 10-inch reflector. I practiced a bit beforehand. And the Massive Marathon is something I did only once, but I'm I'll be talking about that in the next couple of years. Oh, once I did audio, I put it on a cassette tape, and I just started running the tape. And on the tape, I told myself how to find each object. So I listened to the cassette tapes and just did what I heard. I was in Colfax for the next set, but I would also drive down to a place called Red Cloud near Joshua Trees in California, Southern California. 10-hour drive from where I live. From where you are, probably an 8-hour drive in Stockton. And very, very good horizons and dark skies. And I began doing it from memory. Then I don't have to look at charts, don't have to put my glasses on, take them off, and turn on and off a flashlight. A few times I did it with just a blank sheet of paper and wrote down each object as I saw it, which is kind of dangerous because you could end up in the end of the morning and realize you missed something that was in the evening. But worked out okay. And a lot of times I just use my 6-inch reflector with an eyepiece giving a 1.8 degree field of view. Last year, I did a series of experiments using different instruments, and I wanted to see what the experience would be like, is like for others, because I've been using the same instrument all the time, and it's different when you have a big Dobsonian, and I use my big binoculars and stuff like that. There's other types of marathons that can be done too. The photographic Messier marathon was lagged behind the visual Messier marathon by about a decade. People were trying it, but they were unable to get all 110 objects until about the late 80s. And then they began doing it on a regular basis. The photographic and the CCD usually can do a little better than we can visually in twilight. You can do the unaided eye Messier marathon, in which you can probably pick up 40 or 50 objects over the course of a night, just using the unaided eye. Binoculars, we have people who have done that. You can do several Messier marathons throughout the year, 110 objects, you do 25 to 30, 4 times a year, and in 1 year you would have seen all of the objects, and you only need to be out for the first couple hours after evening twilight in order to do that. The city Messier marathon, you're dealing with light pollution. Planet and Messier marathon, the planet Uranus and then Neptune went behind the sun. I think Neptune still is in March, late March. So you might have trouble getting all of them for another few years. You can make your own marathon. For instance, all the globular clusters, there's like 125 of them, and you can put that list together, and that's probably best done in the summer, and just do globular clusters all night long. Massive marathon where you have hundreds. I put together an observing order for the Herschel 400 and plotted them all on the map and everything. That week, the week I was going to do it, clouded out, rained out, so I ended up never doing that. But you can also do the Herschel Marathon or the Caldwell Marathon. But the Caldwell objects put together by Patrick Moore are in both the northern and southern hemisphere, so you cannot see all the objects in one night. I put together a search sequence so that you can pick up the objects in the west before they set and work your way across the sky in a logical order. The objects are set up in groups of 5 to 10, generally speaking. So you begin with the first object and you go through those in that part of the sky. Then you go to another part of the sky and get another half dozen objects and so on. This is one way to make sure you get all of them, and also a way to pace yourself. This is the observing order that most people use. It's been very well publicized. It took a little bit of experimentation to get it so that it works pretty well. I put together a little booklet when I first began and made a lot of notes in the margins on the copy of it, and finally wrote a book on the upper right, self-published, and then Cambridge asked if I could do one for them, so I did. They also translated it into Spanish. So let's run through the Messier Marathon. The Messier Marathon is best done in late March. That's when you can see the maximum number of objects, but you can do it any time of the year. I've done it in 6 of the 12 months of the year. Late October isn't too bad, and August is a pretty good month too. So I mean, there's other times, and I did one last night. So I mean, you can go out any night and see at least 80 or 85 of the objects, and most of the year you can see at least 100. But this is for late March. We begin with M77. I used to begin with M74 the first couple of years, but that was a mistake because I would spend so much time trying to see M74, M77 would slip away. M77 is a galaxy about 9th magnitude, a Seyfert galaxy, very bright center. It's not in the zodiacal light. And you can pick it up in twilight. So you get that first. High surface brightness stands out really well, and then you work your way to the right. M74 is usually the most difficult object in the evening sky. It's the most missed object in the evening sky. And you don't just have to find it, you actually have to see it. So I have had many nights in which I've had the field of view, the object in my field of view, and I've just watched. As it gets lower, the sky's getting darker. But as it's getting lower, you're looking through more haze and more atmosphere. Hopefully there'll be that beautiful point in between where sky's dark enough that you can see it and it's still high enough that you can see it, that you're able to glimpse it. M33, low surface brightness can also be difficult. Then M31, 32, 110. Some people find 31 and 32 and just cannot see M110. Again, low surface brightness. Now, if that happens to you with M110, it will be rising in late March in the morning sky in the northeast just before twilight. So you would have a second chance at that. Now, the next 5 objects take you up to the north. M52, 103. I like doing those in the evening. Some people throw those into the morning where it's also visible. And then M76, the little dumbbell, M34, and then M45. We do want you to look through them, look at each one through your telescope. I know sometimes people say, well, I saw M45 in the finder. I guess that's good enough, but let us know what telescope you use and see every object through your main scope. We then head south. And we begin with M79, then M42, 43, M78. We move to the left of that, and you have a bunch of open star clusters there. Now we have a little bit of time. We can go up a little bit higher, M1, and then some open star clusters, and then M44, M67. And by now, we're at least a half an hour into twilight, maybe not much more than that. And M44 and 67 will be very, very high in the sky. Next, we're going to move north. Oh, no, we won't move north. We hit the stuff in Leo, M95, 96, 105, and then 65 and 66. Then we head north and we get 81 and 82. Those 2 objects will be fairly high in your northern sky too. And the Big Dipper is rising. So you pick up those objects and a little bit further south. And then a little bit to the right of that, you get M53, 64, and M3. Now we're going to go to one of the most difficult areas of the sky. This is the Virgo group where we have a lot of galaxies. I've seen people do this section in 2 minutes, and I've heard that people have taken 2 hours. I would prefer that you do it more in 2 minutes than 2 hours. And if you observe these objects prior to the Messier Marathon and just work your way, practice a little bit through the sequence, you can do it much more easily. It is not something to be feared, but I've talked to people, their biggest fear on the Messier Marathon is this group. We can walk through it, and believe me, you can get it done in 5 to 10 minutes. Now, there's 3 ways to approach it. You can go from the left. and go from that bright star to M60, 59, 58. Glenn Jones mentions that. And he says, you know, you begin with the brightest ones first, and then you work your way to the dimmer ones. You can begin at the far right, and with M98, 99, 100. That's how we're going to do this. And we are working again from west to east, as we normally do with most objects in the Messier Marathon. Now, the third way is to begin at M84 and M86. And just a couple of weeks ago, I saw someone's PowerPoint presentation on the Messier Marathon, and that's what they did. M84, M86 are very prominent in the sky. Once you find them, oh yes, there are two galaxies side by side. From there, you can go north and pick up 4 others. You can go to the northeast and pick up a few more, and to the southeast, a few more, and south. And each time you return to M84, M86, and then branch off each way. But we start from the right-hand side, and this is how we do it. We find this star, which is number 6, the Flamsteed number, and it's about 5th magnitude. And from there, we go to M98, then back to the star, M99, and then we head north, M100, and all the way up to M85. Then we drop south about 2.5, 3 degrees, straight due south for M84 and M86. On the Dobsonian telescope, these directions might be a bit difficult, but remember, north and south. South is always away from the North Star, and north is toward the North Star. So once we get down to M84 and M86, we jump down to M87, which is near a star, and then work our way up, M89, 90, and then the brighter one, M88, and go on over to M91, which was one of the missing objects. From M91, we go south through M90 and go double that distance, and you'll get to M58, a fairly bright galaxy, kind of out there in the middle of nowhere, pretty easy to pick up, and then hang down a little bit to the southeast, and you'll pick up 2 more galaxies. We have 2 more to go in the area, M49 and M61. Instead of heading to the east, we head to the west to see these 2. And then we get back to the finder and find Corvus, get M104 and M68. And sometimes you have to wait for this one to rise, M83. Now we're more than 2 hours into the Messier Marathon. This stuff is rising in the east. M5, M13, M92. And some of these objects don't rise until 1 or 2 o'clock in the morning. But we begin with M57, go to M56. Then two objects in Cygnus, open star clusters, very different from each other, M29, M39, which is kind of hard to find. Some people do have trouble with M39. There's nothing real bright around it. And it does show up in the telescope, but it doesn't stand out very prominently. And then down to M71 and M27 down by Sakita. Now we have these 5 globular clusters, M12, 10, 14, down to M9, and then pop back up to M107. And now we're probably 3 o'clock in the morning. Around then, Scorpius rises. So we can hit M80, M4, 1962, and then 2 fairly bright open star clusters. But during the marathon, you're picking them up kind of low at the horizon, M6 and M7. Now we work our way down the back of the Milky Way. This is a summer Milky Way. I love this stretch. It's fairly easy to do. The objects are just a few degrees from each other. And so you go from object to object. You begin at M11, go to M26, which is kind of a weak open star cluster, but it does stand out. And then 16, 17, 18. Then that star cloud, M24, when you get to M24, you go east to M25 and then west to M23. Continue heading south to M21, which is a little open star cluster, not very prominent, but you can find it in relation to M20 and you'll know what you have. Then M20, M8. And now we go even closer to the horizon for two fairly bright globular clusters, M28 and M22. You've found 100 objects already. Now we're going for the final 10. This can be really low in your sky. And this normally doesn't rise until an hour or less before twilight. M69, M70, M54. And when I did the Messier marathon this morning, that's where I ended up. M54 was my last object. I searched for M15, but could not find it. The others had not yet risen. Now from M54, we go down to M55. M55 is a really bright globular cluster, about 5th magnitude, but the light is spread out over 15 arc minutes or so. So it doesn't show up very well in twilight. Sometimes M55 is an object that people simply have trouble getting, especially if they live further north, 40 or 45 degrees north latitude. They'll have trouble with M55. Then M75, which is a small globular but very high surface brightness. Now we head toward the east. We've been in the southeast. We move to the right a little bit. We're going to finish up with M15, due south to M2, and then M72 and M73. If you do the Messier marathon this year around the time of new moon, you'll be out in 30 days, the 13th of March. And if you go out on the 13th of March and do the Messier marathon, your last two objects will be M72 and M73. If you have good horizons, you should be able to pick them up, but they're going to be tough. But you can get them in twilight, and you can get 109 objects on March 13th. If you go a week before, those objects won't be up yet. But if you do it in mid-March, the evening objects will be higher in the sky. Now, the other option is to wait another month until the next new moon on April 10th. If you do that, you're going to be missing some of those evening objects. But the morning objects will be much easier to see. Now we have only one object left, the most difficult object in the morning sky. And when someone does a Messier marathon and gets only 109 objects, it's usually because of this, M30. M30 normally is not visible from mid-northern latitudes until around March 24th or 25th. From Loma Prieta, I could see it on the 30th, but not on the 27th or 28th. Go further north and you have even more difficulty seeing M30 in late March. So with that, we would have 110 objects. And it doesn't, in a sense, it doesn't really matter how many objects you get. People have their own personal record. Some astronomy clubs have contests to see who can get the most objects. But whatever you get, when you finish up, you can think back over the night. I've seen globular clusters, nebula, galaxies. I've seen all kinds of stuff just within the last 10 hours. It's an amazing feeling to have that, all these Messier objects you've been able to observe. We now have time for questions if anyone has questions.
Does anybody have any questions for Don? I do have a note, Don, about what you said about finding the objects via star hopping. And I think Tim will be able to speak to this too. I've only got the realm of galaxies left to do on my Messier marathon for the Astronomical League. And the AL, under its rules and regulations for the Messier marathon, says you cannot use GO2 telescopes. And actually, I kind of find that a little bit comforting because star hopping is becoming a lost art with all the digital setting circles and such like that. You know, it kind of gives you the instant gratification. There's a little bit of romance and intrigue in trying to star hop from one object to another to find what you're looking for.
There is, and star hopping is becoming a lost art. You're right about that. It was Tom Hoffler and I who had written communications with each other back in the early to mid 80s about this. Because at that time, people were beginning to get these computerized things, which helps you to point the telescope. And I suggested, and we concluded, that if we say you can't use go-to telescopes to do the Messier marathon, you'll eventually lose a lot of people who'll say, I can't star hop. I'm not even going to give it a try. One of the most frustrating things you can do in astronomy is go out and try to star hop when you don't really know what you're doing. Then you can get lost. I still get lost sometimes on things. So we don't want people out there lost at night, not knowing where they're pointed and frustrated. So we decided, yeah, go ahead and do that. The Ventura Astronomy Club used to have the Messier Marathon every year, and they had competition. And they had a separate award for the person who found the most objects with a go-to telescope, and then another award for someone who found them all visually. So you had different categories, and I think more clubs probably ought to do that.
Yeah, I agree. I'm using an 8-inch f6 Dob to do my hunting with. Nice little telescope. The only thing is you gotta wear, those pads on your knees for when you're laying flooring and stuff like that, because I'm a pretty tall guy, so this telescope's pretty low to the ground. Okay.
The Messier Marathon is not like a normal marathon where you're running a lot, but you need to be in pretty good shape. You give your neck a workout, your whole body a workout as you're crawling all around your telescope and repositioning it here and there. So it can be tough.
Yeah, absolutely. Okay, questions for Don. That was really good, Don. I enjoyed that.
Thank you.
Go ahead, Tim.
Fred, I have a question for Don. Don, do you find that there's an optimum eyepiece, field of view, magnification, combination, so that you don't have to continually be changing eyepieces as you go through identifying objects?
Yes. Wide field of view, magnification, at least 18. And probably better to be around 50 to 80 magnification. But the important thing is a fairly wide field, and it does help to have a powered finder. In other words, not a Telrad, although I know many people are familiar with the Telrad, but many of the Messier objects you can see in a 2-inch finder or a 3-inch finder, which does make it easier to star hop around and to find the objects. If you use that type of magnification between, say, 40 and 80 or so, there might be a couple times you'll have to crank it up a little bit. M76 is kind of tiny. M74, you might want to crank up a little bit to darken the background, and then switch back to low power as you go to M33. Also in the twilight, your very first object, M77, you crank up the power a little bit, you can pick it up while it's still twilight. In the morning sky, once you get to the area that M30 is in, go ahead and crank up the magnification a little bit in order to darken the background a bit. M30 has a strong core. If you want to ever pick an object that is going to be the last to be seen, M30 really isn't a bad object. It's about a 7th magnitude globular cluster, and there's a few stars around it. But that might be a time too when you would increase the magnification. But for everything else, you can usually get by with fairly low magnification. 6-inch telescope has often worked for me. 10-inch telescope. A lot of people are out there with 16-inch Dobsonians. Whatever I tell people, whatever you're familiar with, because you know what the field of view is, you know how the telescope moves around. You know what a 9th magnitude star looks like. You know what a 10th magnitude galaxy looks like through your telescope. So whatever you're comfortable with, that's what you should probably use.
Hey, Don, I was just thinking about something. You've done your Messier marathons in a variety of locations, from very dark sites to urban environments. In the urban environments, did you ever have to use any kind of LPR filters or anything like that to
No.
an object? None?
No, I've never used any type of filter for that.
Okay.
You might have to, though, sometimes, depending upon your light pollution. That type of filter will darken the background and give you a little bit more contrast. Again, for nebulous objects, it's not so much light grasp, it's contrast. Contrast is the name of the game, especially down near the horizons at twilight. And for comet hunting, contrast is the name of the game too, which is why I kind of suited for doing the Messier Marathon.
Got it. Other questions, people? Tim?
Fred, one more question, please. Don, in your opinion, would Charles Messier have been able to find all his objects today? I don't know where he was viewing from in France and what its light pollution is nowadays, but obviously in areas where we've got light pollution, these objects are very difficult to find even now. But would he, with his equipment, been able to find them then?
Well, he would have to be somewhere outside of Paris and have better horizons. Paris is a little bit north of where we would ideally do the Messier Marathon. So let's take Charles Messier and put him in New Mexico, Southern California, or Arizona. Give him his, 3-inch telescope with a finder. And yeah, he could do the Messier Marathon. And he would probably be pretty pleased that he could see all the objects in one night, you would think. Or maybe he would think, gee, my whole life's work and I see it all in one night. What's up with that?
Yeah, and Don can do it and take a 6-hour nap in between.
Yeah.
Other questions for Don?
Hey, Don, it's Jeff Baldwin here.
Yes.
Most of my Messier marathons were done at a latitude of 48 degrees, and I have never seen M30 in a marathon, not once in my life. I've done maybe, I don't know how many, maybe 12 or 15. I have never gotten M30. Up there, I was able to get 75 and 15 and 72, 73 and 2, but not 30, never once.
Yep, it's tough in late March, and you probably would have to wait until the first week in April for it to rise in twilight for you, Jeff. 55 might have been difficult too, because that's pretty far south. 69, 70, 54 are pretty far south too, but they have a higher surface brightness than 55. But yeah, that's a challenge. The further north you go, the more of a challenge it is to pick up all the objects. Good job.
Other
Well, I've
questions?
gone 100. Well, I will call 100. I've never gone with 110. So the most I've ever gotten in a marathon is 108. But never got M30, not once.
I've done 110 objects 7 times and 109 objects, I think 18 or 19 times. In Colfax, California, it would always be 109 at the most. I had to go down to Southern California or Arizona to do 110. So, I mean, 109 is fine. Still a great night.
Other questions of Don? So you did one last night, huh?
Yep.
It's pretty good.
I mentioned in the podcast, every month I say once a month I have a segment about the Messier Marathon. I say usually you do it late March, but you can do it any time of the year. And the new moon this month is this day, and the closest weekend is that day. So what would it look like August, if you went out August 15th and did a Messier Marathon? And I spend a few minutes saying you'd begin with these objects in the evening, and then within 2 hours of twilight, you would have picked up 58 objects or whatever. And then your final objects are in the morning are these, and these are the ones that you'd probably miss. So I mentioned it a couple of podcasts ago and thought, well, I'll give it a try here in February. I've never done one in this early in February.
Very good. Other questions or comments? Going once. Going twice.
You're not muted. You're good.
Okay, hi, Don. This is a pretty simple question here, but I assume you moved to Arizona for one reason, to get really dark skies. How dark does it get there typically, and what's the darkest you've ever had? It sounds really exciting to be able to work in a dark area like that.
Well, it's between a Bortle 2 and a Bortle 3. The smaller the number, the darker it is. I have a copper mine that's 22 miles to my south-southeast, and they light it up all night. So I have a glow in my south-southeast. Prescott is about 40 miles to my east, and it gives me a very tiny dome. And then Las Vegas is 100 miles to my northwest, and it gives me a tiny glow. Otherwise, it's fairly dark.
That is awesome.
How many nights a year do you say it's clear, Don?
200, but at least 200. But it's different here with the changing of the weather. It can change quickly. You can have it, clear at 4 a.m. and at 6 a.m. you have the clouds coming in. And that type of pattern happens fairly frequently, not with that particular time of the morning, but it can be cloudy in the evening and a few hours later it's clear. I did not see that so much in California. In California, once the clouds come in, they usually stay in for a few days. Once it clears up, it will usually stay fairly clear for a few days. And we do have our long stretches of fairly clear skies, and then you might have a couple of nights of clouds.
Okay. Yeah, it's raining here.
Yeah.
All right. Other questions or comments, people? All right, Don, thank you so much. That was great. Really enjoyed it.
Thank you. Thank you.
All right, Mike, turn it back to you.
Okay, thanks again too, Don. That made the evening for a rainy night. I don't think we could expect much better than that. That was wonderful. A lot of fun.
Good audience. Thank you.
Okay. Well, we have a a student ambassador that we have in our club now. That's Nihar. And I believe you're on the air. Is that right? Nihar?
Yes,
Okay.
I'm here.
Okay. Hi. Just kind of want to introduce you to everybody. And I'm just wondering if anything has gone on since we last talked to you.
I saw the conjunction, the Mars and Uranus one.
All right, good.
Yeah, that's good. All right.
Was Uranus easy for you to find?
Yeah, it was pretty easy. I think it. I can see it from my backyard. So.
Wow. Okay, sounds good. Okay, Fred, anybody in the executive committee or anybody here right now, any announcements to make or anything going on? It's kind of slow right now, obviously, with the COVID thing. Any news items that we should address or talk about?
I can give everybody a heads up for next month. As a follow-up to Don's excellent presentation, we're going to have a little bit of abbreviated presentations. Tim has requested a variety of lunar images, which he's going to talk about in regards to certain lunar features. And then maybe Jeff can jump in on some of the Messier marathons or Messier observing he has done. And we will scare one or two more people out of the woodwork for, 15-minute presentations each or something like that.
Okay, very good. Okay, anything else? Anyone else have an announcement to make or have questions or concerns?
Just listen.
Okay, Jeff is going to announce the raffle here, the raffle winner.
All right, Mike got a In-N-Out Burger gift card, and I did my little dice roll, and our winner this month is Paul Kovacic. So congratulations, you've got yourself an In-N-Out gift card.
Wow, thank you.
Yeah, I can mail it to him, or next time we see each other, get it to whatever works. Congratulations.
Thank you. Thank you.
You have an In and Out in your neighborhood?
No.
No. But I'll find one.
Well, then you got an In and Out bookmark.
Pardon me?
In that case, you got an In and Out bookmark since there's no In and Outs up there.
All right.
It's good for a
I'll find a
lifetime.
place.
Don't think-
In 8 years after COVID leaves, maybe there'll be one by then.
All right.
Indeed. Okay. Anything else, folks? I guess this is pretty much the presentation here.
Yeah.
All right. So we'll sign off here. I wish everyone stay safe. We'll see you guys again next month. And take care.
Thank you very much, Don.
Thanks, Don.
Everybody,
Thank you.
Great talk.
great
Thank you, Don. It was
presentation.
great.
Thank you. Thanks for the invite.
Thanks, Don.
You're welcome. You're welcome. Good to see you all.
Good to see you.
All right. Take care.
That was good.
All right.
That's
So we're
good.
gonna click it off here.
Yeah,
Or...
might as well.
Bye, guys.
Bye-bye.
Bye now. Good night.
Night.